There are 6 types of organic reactions. First, I'm going to show you how to identify each one so that you can recognize which reaction has occurred, and then we'll discuss how to predict the products of each of those types of reactions. Each of those will be a separate lecture. These reactions will not be in the order that is listed in your notes. I'm going to list them in an order that makes the best sense for you to identify the type of reaction. The first reaction we'll look at is called neutralization. This is one you already know from our previous reactions as a double replacement reaction. In organic chemistry, we call it a neutralization reaction. In this reaction, you will need an acid and a base, and it will produce a salt and water. Generally, the quickest way to identify this reaction to see if it's occurred is to see if you have a salt. In this case, that may mean it has a positive charge and a negative charge in the products. That may be the easiest thing to spot. And for this class, that's what we'll look for. Our first reaction then is neutralization, and for that we will see charges on the product side. Our next reaction will be oxidation reactions. Oxidation reactions are easy to identify. We'll be looking for an oxygen above the arrow in the reaction or an O2 oxygen on the reactant side of the reaction. Oxidation reactions allow us to add bonds to oxygen in these compounds. So far, we've talked about neutralization or double replacement, in which we will see charges on the product side of the reaction. For oxidation reactions, we're going to see oxygen either as a reactant or over the arrow like a catalyst. And now we're going to talk about addition reactions. Addition reactions start with alkenes and alkynes, so double bond or triple bond, and they add something on both sides of that bond. So we can add hydrogen, we can add bromine or chlorine, one of the halogens, or we could add water. In any case, we're going to add something on both sides of the double bond, and we will see our products. So how we will find addition reactions is we will look to see if there's an alkene or an alkyne on the reactant side, double bond or triple bond. So far, we've seen neutralization reactions, where we look for charges in the products side, oxidation reactions, where we're adding bonds to oxygen, and we're looking for an oxygen on the reactant side or labeled like a catalyst above the arrow, and addition reactions, where we'll be looking for alkenes or alkynes, double bonds or triple bonds, on the reactant side. Now we'll be doing substitution reactions. In substitution reactions, we only see 2 types of reactants. They are the alkanes and the aromatic compounds. These 2 compounds are particularly unreactive. They can only do one type of reaction, and that is substitution. In both cases, we'll be substituting a hydrogen with a halogen. Again, this is the only reaction that alkanes and aromatic compounds can do. So we'll be looking for anything that has an alkane or aromatic compound on the reactant side of the equation. So far we've discussed the first 4 reaction types. Neutralization, where we look for the charges in the products. Oxidation, where we look for oxygen on the reactant side or over the arrow inside of a bracket. Addition reactions, where we expect to see alkenes or alkynes on the reactant side. And substitution reactions, where we're going to have alkanes or aromatic compounds as our starting material on the reactant side. Now we're going to focus on the condensation reaction. In the condensation reaction, 2 compounds come together, they condense, and they form water as one of the products. Water as the product will be our clue that we're doing a condensation reaction. There are other reactions that do have water as a product, so you must eliminate those first 4 first. If it isn't one of those 4, then it's going to be one of these last 2, condensation or hydrolysis, and condensation has the water on the product side. In a separate video, I will tell you about the reactants and the products for this reaction. We've now done the first 5 reaction types. We've done neutralization, where we look for the charges on the product side. Oxidation, where we look for oxygen on the reactant side or above the arrow. Addition reactions, where we look for carbon-carbon double bonds or triple bonds on the reactant side of the reaction. Substitution reactions, where we look for alkanes or aromatic compounds on the reactant side of the equation. And condensation reactions, where we look for water on the product side after we've ensured that it has not been in one of the previous reactions. And now we'll do the last set, which is hydrolysis reactions. Hydrolysis literally means breaking with water, and that means that we're going to be looking for water on the reactant side, and it will be breaking the compound right at the oxygen or nitrogen that joins the two halves together. When we're identifying this type of reaction, we have to ensure that it is not one of the first four reactions which may have water on the reactant side. Our last choice will be to look for condensation or hydrolysis reactions. Hydrolysis will be the one with the water on the reactant side. That is all 6 types of organic reactions and how to identify them. Number 1, we have neutralization. We look for the charges on the product side of the reaction. Number 2, we have oxidation, where we look for oxygen on the reactant side or over the arrow. Number 3, we have addition reactions, where we'll be looking for alkenes or alkynes on the reactant side. Those are carbon-carbon double bonds or carbon-carbon triple bonds on the reactant side of the equation. Number 4 is a substitution reaction, where we'll be looking for alkanes or aromatic compounds on the reactant side of the equation. And number 5 and 6 are related to each other in that they are both looking for water either on the product side or the reactant side. Because these two don't have a great identifier, we have to make sure that it is not one of the previous 4 reactions before we look at these two. So if we find water on the product side, we know that it is a condensation reaction, or if we find it on the reactant side, it is breaking the chemical apart and it is a hydrolysis reaction. On your exam, you will be given a choice of what type of reaction it is for about 5 questions. This gives you an idea of how important it is to be able to identify it. You will also be asked to predict the reactants and products in several different equations. We'll discuss that in a future video.